All right. Okay, let's take a look at this one. Calc 30 here, 2.3, number 2k. So this one's a bit tricky if you're asked to find the derivative here. Okay, so find derivative. That would be u prime of t. Is it still frozen? Oh, sorry. So if you're asked to find the derivative here, a couple things we want to know, or we want to make sure we remember, is that the function is in terms of t. The actual variable that is used to graph this function is t. T is the variable. When this is the letter that's in here, that's the variable. So you see it here and here. If you have other letters, in this case A, B, and C, that means that they are constants. They're not actual numbers like 5 and 17 and 3. They're just A, B, and C constants, okay? Right now they're an unknown. But we have to treat them like numbers, okay? So in this one's going to be a bit strange because we're going to have the derivative is going to be in terms of a bunch of different letters and the variable t, okay? They're going to stand in place of the numbers. So the second thing you want to make sure you remember is that this t, okay, in the denominator and this t squared in the denominator, they should be written in the numerator, even if it makes them have negative exponents. That's okay. So let's just do a little, rearranging here of u of t. So a can stay. I'm going to rewrite this as plus b, because that's the number, times t to the what? How can I bring this up and what do I have to write it as? Negative 1. Very good. It's t to the positive 1 down there right now, but let's bring it up and make it t to the negative 1. So then I have c, just a regular old number, times, and how do I write t squared that's in the denominator? How do I write that in the numerator? That's going to be t to the negative 2. Okay, pause there. Everyone see how I rewrote that to make just a term with no denominator, with no at least a variable in the denominator? Okay, at this stage, power rule, sum difference rule, constant rule, it's all you know. So you have to write it like this, then you can go ahead and do your derivatives, all right? Now let's find u prime of t. Remember, a is a number, a constant. So what's the derivative of a constant, a number? It is 0. Very good. Okay, so now I'm going to add this term. When I take the derivative of this term, remember the rules. The power rule says that this exponent has to come down and multiply by this number. So I'm going to have, and I've already written the plus, which is fine, but it's going to be negative b. You see that? To the times t to the power of what? Negative 2. Very good. You still subtract 1 from the exponent when you're taking the derivative. Okay, very good. Now that's looking kind of funny, right? It's all right. This is the process. Stick with it. So now I add this term, and the derivative of this term is going to be negative 2c. T to the power of negative 3. Very good. Okay, you guys are awesome. So let's do some simplification here. Get rid of these brackets. Get rid of the negative exponents. Okay, get rid of brackets. Get rid of negative exponents. Rewrite them like that. Because look, we don't have any negative exponents in the question, so let's leave the answer in a similar fashion. So I'm going to write negative b over t squared. See, this becomes now a positive, 2 down there. And plus minus, well, that's minus 2c. This is going to go down to the denominator. It's going to be over t cubed. Okay? That's fine. If you see that we have a negative 1 as a common factor, then congratulations. You can pull that out and factor this. So simplified answers in calculus usually have no negative exponents. They usually have fractional exponents only if the question has fractional exponents. Instead, you would write those as radicals. And if there's any common factors in your resulting expression, any greatest common factor in the expression, you should pull that out too. Okay? So this would not be a big deal. The back of your book might even give this as the answer. I don't even know. Yeah, it does. This is the answer. So I would challenge you, if you notice this, then great. Your final answer could be something like this. Negative b over t squared plus 2c over t cubed. Okay, that is factoring out a greatest common factor. So right now, both of these answers are totally fine. But it would really change things if there was a 2 here. If there was a 2 here, then you would say, oh my goodness, I have to take out a negative 2 as a common factor, and you would be absolutely right. So why not take a negative 1 out, right? This is my argument. Okay, any questions about this one? It's a bit funny with the constants as letters, right? But any questions? Okay, fairly confident in this one? It's not freaking you out too much? Yes? Yes, you're confident, or yes, it's freaking you out? All right, that's that question. We'll do another one.